Now, let's switch over to the DAW and let's get into more serious things, and we'll can stop looking at my nice little drawings. All right, let's start by, let's start. So let's start by the oscillator. We're going to be using operator here in live, but if you're, whichever synth you feel comfortable with, go ahead with it. Basically, in the pathing in the interface, it's usually first thing you see, first thing on top left, you'll have your oscillators. So operator has 4 oscillators that you can stack on in different ways. We'll start with the oscillator A for now. We can play around with our oscillator here and choose start by choosing a waveform. So let's start by doing that. Let's listen to different waveforms. We're gonna look at the spectral analysis of these waveforms right here while we switch them up. Okay, so this is starting out by a sine wave. Okay, so there we have it. Sorry, I started out a bit too low there. I didn't check what octave my keyboard was on. Sorry about that. Let's look at a saw wave. Let's look at a square wave. Now let's look at that triangle wave. All right, so as you can see, I was playing the same note from one oscillator to another, but hopefully your ears and your brain interpreted all those sounds a little differently. Now the sine wave, as I mentioned earlier, is a very pure, simple waveform. What you're getting out of it is the only sound that's playing is the frequency at the fundamental, the root of the sound. So if I'm playing, this is a C note this is C2 at 132 hertz. If it's a sine wave, we're only going to get that specific frequency. And this frequency is called the fundamental. Now, when we start getting into more complex waveforms, it's going to start bringing out harmonics, which is what I was talking about earlier. If we look at this, saw wave, we're going to get the fundamental is still there, but we're going to get a note or sound that's right here, which is twice the frequency of the fundamental, so technically 1 octave over, and then we're going to get a sound that's 3 times the fundamental, 4 times the fundamental, 5, 6, 7, 8, so and so on and so forth. And that's the main characteristic of a saw wave. You're going to get every even and uneven or odd and even fundamental, and it's going to decrease in a linear fashion, linear as opposed to logarithmic. I'm not sure how to translate that to English. Logarithmic or exponential. There you go. Would be a good term. Feel free to correct me on that, by the way. All right, so let's look at other waveforms. If we look at the square, seems very similar. I'm just going to clear this. So now we're getting the fundamental and the odd frequencies. So the fundamental times 3, 5, 7, 9, 11, and that's the sound we're going to get out of a square waveform. Now, why is this important? Well, that's pretty much what you want to play around with when you want to mess around with your sounds. And one thing that I really like about operator that's kind of different from the other synths, or I haven't seen this in this function in a lot of other synths, is that you can actually draw out the frequency spectrum you want from your synth. And so this is your fundamental, and each little subsequent bar that you see there is a harmonic. So as you can see, the harmonic content has a great effect on what's going on here, and it's a very important thing to consider when you're programming your synths. So from the oscillator, we're going to get into the envelope, which is, boom, right here. So we have a nice little drawing. So as I was saying earlier, the envelope is an amplitude modulation that's triggered by the fact that you press the button. So what happens when you give the note on is the note's going to start out at its minimum sound, so at no sound, and it's going to gradually go up to to a first peak. And the amount of time that it's going to take to get up to this peak is called the attack. Now, the important thing to remember with the attack phase is that it is a time. Now, bringing up the attack, if you want to add attack to a sound, one term that's used, you're saying you want to add attack. Usually when you say you want to add attack, you want to make it punchier at the start. Well, if you turn the attack up, you're technically making it less punchy. So let's see what happens. So this is the attack at 0, and now it gradually rises to this peak point. The decay is the amount of time, which is right after that. So we can see this is our 1 second attack, and after that it's going to get into the decay phase. So decay is also an amount of time. It's the amount of time it's going to take for the level to drop to the sustain level. So the decay and sustain are linked together. So I'll give you another example. So as you can see, it went to the attack in 1 second, and then in 1 second it went down from its peak down to minus 19 dB. Let's put this back up to the release. In this case, will be the amount of time it takes for the level to drop back to 0 once I release the note. So now it's 60 seconds, which is super long. You don't really need to be that long, but for example's sake, there you go. So that's what the release does. Okay, so that is envelope. Now, envelope in this case, putting a certain emphasis on it as the envelope on the amplitude of an oscillator, but technically we'll see later that envelopes can be applied to other parameters, and you can have modulation envelopes that can be applied to other stuff, which is lots of fun, like the filter, which I guess we are now ready for. Now, since we're going to be using filters, we're going to go ahead and switch to the SAW waveform, because, like I said earlier, it has a lot of harmonic content. Okay, it releases way too long. There we go. Okay. Cool. And we're going to get to the filter part of this synthesizer. I know the LFO's up there before, and we want to get into that because we've all heard about what the LFO does, but we're going to do the filter first because I said so. Okay. As you can see, I just turned on the filter, and we've got a frequency and a resonance. Now, the frequency is, oh, sorry, I should say there's filter type chooser. There's the frequency and there's the resonance. now, to start with this first example, we're going to start with a low pass 12 dB filter, with which we can play around. So the low pass filter is going to let pass frequencies below the frequency of your choosing. As you can see, it is making the frequencies above 674, which is right around here, making them curve down a little bit lower compared to this. There we go. And the resonance is a gain that's added to the frequency resonance, the frequency of your choosing. So this sounds kind of weird, but I'll just give you an example. Sort of emphasizes the frequency where you're cutting off, just so you have a more visual way of seeing it. I'm just gonna throw in, where is it? Yeah, audio effects. Sorry, I'm not used to Ableton 9 yet. We're still this is the filter, so we're now external to the operator. But this is in this case the frequency is here, and the resonance is here, and you can see which frequencies in this little graph are being cut and which are being emphasized when I play around with the resonance. So why would you want to emphasize the frequency? Well, it's a cool little effect. You can hear the sweeps better when the resonance is up when you're playing around and automating, for example, your frequency.